In this video, we will discuss how to derive the inverse kinematic solution of a Scara manipulator. In a Scara manipulator, the top view has elbow down and elbow up configurations. For the elbow down, we will use the positive angle to derive the inverse kinematic solution, while in elbow up, we will use the negative angle. You can choose only one in this configuration, but remember, the elbow down solution is not equal to elbow up, but we can choose either of these two solutions. Now, we will choose the elbow down in the Scara manipulator, the positive angle. Now we can start the derivation of our inverse kinematic solution. So, we have here the Scara manipulator, the top view and the front view. So we will start the derivation in the top view. So at the top view, it is a elbow up, and we will use a positive angle to make use of our trigonometric function for our inverse kinematics. Using graphical method, we need to find triangles. So as you can see here, the y sub 0 is pointing upward. So we will draw a y sub 0, 3 here, from end effector, so this is given because y sub 0, 3 is a position vector. So next is along the x sub 0. So we will draw a Now, we have the two sides which have given values, and we have here a right triangle. So now we will draw a hypotenuse from end effector, up to the base, and we will label it as R1. So now that we have a hypotenuse, we will use this to solve for theta 1. Since theta 1 is not the angle of the opposite side of y sub 0, 3, we will make a new angle and name it as phi 2. Since phi 2 is inside theta 1, the phi 1 will be here. So we have here phi 2 is equal to theta 1 plus phi 1, and if we will arrange it to solve for theta 1. So we have theta 1 is equal to phi 2 minus phi 1. So we will need to find the value of phi 1 and phi 2 to solve for theta 1. So we will box this because this is an equation. So now we have the value for theta 1. Next, we will derive what is phi 2. So phi 2 is the inverse tangent of y sub 0, 3 over x sub 0, 3. So we will box this and label it as our first equation. Next is we will derive what is phi 1. So phi 1 is inside another triangle, and this triangle is not a right triangle. This is a scalene triangle, so we need to use the cosine law. But we don't have yet the value for R1, so we need to get the value first. R1 is a hypotenuse, so to solve it, we will use y sub 0, 3 and x sub 0, 3 using Pythagorean theorem. So R1 R1 is equal to the square root of y sub 0, 3 squared plus x sub 0, 3 squared. So now, we will box this and label it as our equation number 2. So now that we have our R1, we can now use, or we can now get the value of our phi sub 1. Since phi sub 1, as what I have said, is a scalene triangle, so we need to use a cosine law. So phi 1 is equal to inverse cosine times a sub 4 squared minus r1 squared minus a2 squared over negative 2 r1 a2. So we will box this because this is our third equation and this will be our fourth equation. So now that we have the values here, we can now solve for our theta 1. So to solve for theta 2, we need another angle, which is phi 3 here. So we need phi 3 here because this is a straight line from the base up to the side of theta 2. So this is a half circle, so it means this is 180 degrees. So 180 degrees is equal to phi 3 plus theta 2. So if we arrange it to get the theta 2, we will have theta 2 is equal to 180 degrees minus phi 3. So we will box this because this is an equation. So now that we have our theta 2, we will derive what is phi 3. So since phi 3 is inside another triangle that is not a right triangle, so we will use the law of cosine. So inside this triangle, we can see that we have three given values, which is a4, a2, and r1. So the opposite side of phi 3 is r1. So the formula would be phi 3 is equal to inverse cosine times r1 squared minus a2 squared minus a4 squared over 2a2 a4. So we will need this to get the value for phi 3. And we will box this because this is our fifth equation and this will be our sixth equation. Now, we can solve for theta 1 and theta 2. This Scara manipulator also has a prismatic joint. So we have here a front view kinematic diagram. And as we can see here, our end effector is pointing downward at the front view. And in this view, we can now say that the given element here is z sub 0, 3. So z sub 0, 3 is given. So to solve for d3, we can derive z sub 0, 3 is equal to a sub 1 plus a sub 3 minus a sub 5 minus d3. Minus d3 because the direction of our end effector is pointing downward. So to solve for d3, we will arrange this to d3 is equal to a1 plus a3 minus a5 minus z sub 0, 3. So this will be our seventh equation. Now, we have the formulas to solve for inverse kinematic of the Scara manipulator using graphical methods. We have the total of 7 equations. That's all. Thank you.